Thank you for everyone for being here. Thank you for this space to talk about this topic with you. As I was introduced by Christine, I'm a PhD student. I just started my PhD in the summer, and the presentation today, I brought this topic that's related with my research in the laboratory. That's the use in paper residues to produce paper pellets to generate energy. And the agenda for this presentation, we're gonna see some data from the greenhouse gas emission in Canada and Quebec. How is the issues faced for industry and how it's related from the greenhouse gas emission. Doing pellets, how is the pellet market nowadays in the world? How is the production and chemical composition of paper, as we have a different type of paper, and these different types can affect the profits and the commercial of our pellets. It's really important to know where does this paper come from, how it's made, how is the composition, how we made the pellets production, how is the whole process. And we're gonna see about the certification and pellets properties as well, that make sure we are producing pellets with a good quality to give to the final client. And here we have a pie chart of the greenhouse gas emission in Canada. In the left side of the screen, you have the pie chart for Canada, and we see that most of this gas emission comes from the transport sector and the industry sector for the first responsible. And then the right side of the screen, you have the pie chart for the Quebec, that Quebec is responsible for 80% of the gas emission in Canada. And the province of Quebec, most of the emission of this gas comes from the transport sector and the industry sector. So if we added these two sectors, they are responsible for over 70% of the gas emission. So if we made some efforts to change this things in this sector, we can have a significant impact in the gas emission. And Quebec has the target to reduce the gas emission, the greenhouse gas emission, the amount of CO2 equivalent released in the atmosphere of 37.5% by 2030, below the levels of 1990. So to hit these targets, to work in these two sectors will help to reach this result. So what's the issues that we have? Usually in the industry, they use coal and natural gas to generate energy. And this source of energy, they are responsible for most of the CO2 emission in the atmosphere. So they have this high emission. And also in the industry, they have, in their process, the residues that usually goes, these residues go to the landfill. So here we have two problems, the environmental problem with the landfills and the high emission of CO2. So the idea of the research is to use these residues that sending to the landfill to produce pellets from this biomass. And producing pellets, we are going to generate energy from a renewable source that will reduce the CO2 emission in the atmosphere, and as well as replace the source of coal and natural gas to generate energy for this industry. So as a target to reduce the CO2 release in the atmosphere, Canada has also the target to reduce the landfill use of 30% by 2030 and 50% by 2040. And they have the implementation of the standard on clean fuel as well. This is standard initially for liquid fuels in 2022, and gaseous and solid fuels in 2023. So this effort in this using this residual, biomass residue to make pellets will help, will support the government to hit those targets of decrease in the use of the landfill and reduce the CO2 emission. And here you have a wood pellet market information that bring the knowledge to know how the pellet market in the world is expecting to increase, because not even in Canada, but most of the other countries around the world, they are looking for renewable resource to replace fossil fuel source to generate energy. So pellet is a really good option to generate energy in this case. So this market is expected to increase in the next year, and it's expected to reach 15.63 billion by 2026, and a compound annual growth rate of 7.28% during the period of 2021 to 2026. And here in Canada, we have this Canadian biomass pellet map that shows that Canada already produce a lot of biomass pellets. And specifically in Quebec, here we have 10 current producers in Quebec, and the most capacity of production of these current producers is 210 tons per year. In these two plants of biomass pellets located in Chapelle, sorry if I say the name wrong, and Saint-Michel-des-Saints. So here I will have a scheme from the cellulose production for paper. Paper is made from cellulose. Cellulose comes from the biomass. So to have this, we have to get this biomass, reduce the size of this biomass, and then we cook this biomass using some chemical compounds to separate cellulose and lignin. And then you remove this lignin from the pulp, and we go with this pulp to the bleaching step that is for change the color to get the cellulose whiter according to the kind of paper we are producing, depending if the paper you need the paper whiter or not, because some paper you don't need actually to bleach the cellulose, but for other, yes, depending on kind of paper. And then we have to dry this paper, the cellulose, to remove the amount of water, and then we pack the cellulose and sent to the paper industry. So here in the paper industry, they're gonna use the cellulose to produce different type of paper. And according of any type of paper that we are producing, they're gonna be different in the chemical composition. And here we have a slide that shows the different compositions of some papers. Depending on the paper we are producing, we can add some additives. In this case, as here we can see, we can add some charts using kaolin, calcium carbonate, for example. If we want a paper with more resistant to the humidity, we can add some resins and polyamide. If we want to add any color in the paper, we can use some colorants and pigments, and adding these additives in the paper production will change the composition of the paper, so it's going to be different from each other. For example, here in this table for the cardboard, it's a paper that requires mechanical properties better because they have to support the weight. So we add some charts in this case, and this amount of additives of inorganic it doesn't go over 5%. But if you're gonna produce printing or reading paper, we added more additives in this case because the cellulose, the surface of the cellulose is very irregular. So through reading and printing in this paper, we need the surface less irregular. So we added more inorganic things in this paper, in this case, in the production of this paper to get these properties. So that's why we have a more amount of inorganic compound in this case that can hit up to 30% of additives in the paper. And another example, that's the opposite, that's the tissue paper. The tissue paper, we want the property of absorbance. We want that this paper absorb humidity, water to clean the stuff. So that's why we don't use a high amount of inorganic compound in this case, because we want to keep the property of the paper, the absorbance property in this case. So here we see that depending on type of paper, we have different compound, and this amount of inorganic compounds in the paper will affect our pellet paper production, and will affect the combustion of these pellets. So understanding where our paper comes from, it's very important when we're gonna make pellets with better quality. And here the pellet production process, how we make the pellet. Pellets is a solid biofuel that we compact this biomass to produce the pellet. So we're collecting these residues, these paper residues. You have to grind this paper to make an homogeneous samples to bring to the next step, the drying step, where you want to remove the water that's in the sample. Moisture in this case, it's not desirable in the pellets because the humidity they doesn't help in the combustion system. If your pellet has a high moisture content, it's gonna retard the combustion, the ignition time of your pellet, and it will decrease the calorific value as well. So that's why it's really important to remove the water of the samples. And after we dry these samples, we go to the pelletized machine where we're gonna compress this material to form the pellet. And forming the pellet, we're gonna cool down this pellet to allow stabilize the extractor. So at this time, they're gonna lose the temperature decrease, and the extractor of the biomass start to be stabilized. And then we are good to sieving this material. In this step, it's really important to remove the fines that we produce in the pellet, because fine is a problem as well in the combustion system and the transportation. So we need to remove this amount of fines to avoid some problems in the future. As soon as you sieve that, we packing and storage this pellet to send to final client or to use locally. Here, after we produce the pellets, we have a standard and a certification that requires some properties from these pellets to allow this pellet to have a good quality during the burning, and focusing in some specific properties that make sure that the final customer will have a good quality of pellet to generate a good quality, a good amount of energy, and avoid any problem during the use of this pellet as well. And here we have some properties that the certification CANplus. First, this CANplus is a seal that's given to to the pellets, and it's divided in two categories. That the category A, it's mostly for private domestic use in boiler or stoves. And we have the category B, that's greatly used for industrial pellets. That's a bit more flexible when you compare with domestic use. So this certification gives us this some properties to some ranges to have the pellets in these categories, value categories here to ensure the quality of the pellets. And they look for the diameter, length, moisture content, no more than 10%, as we talked before. The reason of not having a high amount of moisture content in the pellet. Ash content is a really important property in the pellet, and it's different because, as we see before in the chemical composition of the pellet, depending on the paper that we have a different amount of inorganic additives in this paper, and it's gonna interfere in the ash amount, because the higher inorganic compound you have in your paper, higher will be the ash content. And ash content, it's not desirable in the pellets, a high amount, because it can doesn't allow you burn regularly the pellets that you have in your stove, and you're gonna producing a high amount of ash. You also gonna have to stop more often to do the maintenance of the stove, of the burning system, and maybe depending on the type of chemicals that you have in your sample, problems with clinker or anything that would make you stop all more often to make this maintenance. That's not good. You stop to generate energy. And durability, it's also an important property as well, because when after you produce the pellet and you're going to storage that, you're going to transport that, and you're going to send this to the final client, these pellets, that they're going to have some impact during in the structure during this transportation. And according, if they have like a lot of impact, they can break. So that's why the durability is how much how can your pellet can support this impact, and we measure that in percent. That's gonna give us, they have a strong structure to reduce to avoid the pellets break, because breaking, we are losing material, we are decreasing the high calorific value, because we are losing biomass and we are producing more fines. And as we talked before, fines also as a problem in the combustion system and the transportation as well. And high calorific value, you must have a biomass that's allowed to give a minimal high calorific value to produce the energy. And bulk density is a property that measures how much pellet can you put in a specific space. So here we have a table that shows some properties of wood pellets, raw paper, and paper pellets. What we can see here is comparing our raw material, the paper, with wood pellets, the wood pellet, the wood used for made pellets, compared with paper for made pellet. And I brought some properties that we found in the literature. Wood pellets, these values, they follow the certification. Wood pellets methodology, the manufacturing of wood pellets, well known in the literature. So it's a good zero to compare the values to have a good quality of the paper pellets when we are producing. And here, moisture content, we see that's not over than 10%, as the certification allows us. But here, for raw paper, we have For example, in this case, waste craft paper and waste paperboard, the author found around 5% of moisture content. We have a less amount of moisture in papers because actually this biomass already passed for a treatment for a drying process that's change the chemical structure of this biomass, so it doesn't allow this material to absorb water as it was able before the dry this material, as the wood works like that. So that's why we have a low amount of water in this case. And for the paper pellets for cardboard and paper towel, in this case specifically, the author was working with the different moisture content. So that's why we have 15% in both cases here, because the author fixed this value. And heat ash content for wood pellets not over 1%. That was required in the certification, but as we discussed before, paper has a higher amount of ash content. That's gonna lead us to the problems of high amount of ash. So we need to work to reduce this amount of ash that that's come from the paper that we are using. And in this case, for the paper pellets, we see that the values of ash in cardboard and paper towel, it's similar the amount that of inorganic compound that you see in the table before, that's more high as it's in the craft paper or waste paper. That's why it's really important, again, saying to know what type of paper you are using and where it's come from. And here the high calorific value, we see that wood pellets, has the high calorific value that's required in the certification. For paper, in both cases, the raw paper and the paper pellets a bit lower, but it's still a good amount. And we see here that paper is a biomass, and it was using residuals paper that's to generate energy. You see that you can use a residue that you used to send to the landfill, and you're doing nothing there to generate energy for your industry, replacing the fossil fuel source to generate energy. So it's really good numbers to see here that using residuals, we can have almost like a good amount of high calorific value as would have to generate energy. So it's a good source to produce energy in this case. So the valuation of energetic pellets, using pellets as a source of energy, its efficiency to produce heating, its uniform in size, shape, energy content, and moisture when you compare with other biomass. And it's easy to transport and storage as well. It's also considered carbon neutral or close to neutral, because when you burn the biomass, the paper pellets, the amount of CO2 released in the combustion is almost the same, the amount of the CO2 that the trees absorb during when the tree is growing in the forestry. So that's why it's considered neutral. And using biomass as a source of energy to produce energy, we are releasing less salts and NOx and CO2 as well, and particles matter in the atmosphere. Here we have a picture of the team, the team that makes all the projects in the laboratory work. So many thank you for everyone here. Thank you also for our partners that work with us in the laboratory, yeah, and the founding agents as well. And thank you for watching this presentation. And now I'm open to answer any questions that you have. Thank you so much, everyone.
Yeah. Exactly. Great presentation, great work. It was exactly the popularization level we were looking for. So thank you for your work in your presentation. And it's time for questions. So people, you can raise your hand, open your mic, or write it in the chat, and I will tell to Rafael. You have comments, very interesting. Good presentation. In your studies, Rafael, what is your biggest challenge? What the biggest challenge you meet as a person?
As a person?
Yeah, but in your work, but yeah.
I like you mean when during the research, what the work that I'm doing in the lab?
During the research.
Oh yeah, I'm facing like some challenge like to process the material that I'm working with, because as we have a different type of paper, they respond the process in different way. So, but I need to use all this material together and to homogeneous this sample. It's quite a challenge as well. And specific for paper, the combustion system, it's also a bit different when you burn wood pellets as well. So you need to adapt the system, because like we're gonna have a higher amount of ash. We have to look a way to maybe decrease the amount of ash that we have in the sample, and in the combustion system to do anything that support the an amount of ash, a higher amount of ash, like to look for a point that you have a good variables, like a good way to produce to burn to construct the system and to burn this pellet. We also, for example, compare with the wood, we need more air in the system than burning wood pellets. So working with paper, it's not that easy when we to produce a pellet. When you listen, that's kind of just uh, reduce the size of the pellet, compact it, and burn it. That's gonna be okay. But we have a
Can
lot
you
of
find
trouble.
do you have different methods in the literature to help you find the great way to process the different kind of paper waste?
Yeah, I actually have a different way. Like some people, for example, to reduce the size, they use blades. They use grinders. Some people use a hammer. Uh, oh, I forgot, hammer machine that helps to reduce the size as well. And in some papers they use a mini cutter, the mini a paper shred with reduced size, and we are facing to test what type of this methodology works better for our sample, because as I told you, different type, it doesn't it's not responding as we are expecting for it for the different methodology.
Thank you for your answers. I have two questions in the chat. One from Eric Wolf Wolfart. I don't know if I say well your name. I'm sorry about it. What strategies can be used to reduce the ash content when using paper as a source for pellet production?
Okay. We we can try to use like to make some wash in this case, like to first of all, we need to know what kind of inorganic compound we have in these samples to see what kind of methodology can we use to actually remove this amount of ash. And we we are making the characterization of this material to know better the chemical composition of the samples, to apply a better way to reduce. But actually, now we are waiting for this for get these results to apply in the methodology to remove the ash. But actually, we're gonna use a kind of washing things to reduce the size.
Thank you.
We have a question here from Daniel.
Yeah.
Sorry. Okay, you were talking about separation lignin cellulose for the press. Okay. Yeah, there are some studies using the lignin for pellet production. Lignin can be used, for example, in the paper pellet production as an additive to help the the lignin works as an adhesive to help to make the connection to link the papers. And these properties in the wood pellets work as well, because when you increase the temperature in the wood as well, over 70 degrees, for example, you melt this lignin and is able to wrap the material, and when it cool down, it's glue all the material. So you can use in the lignin to use the pellets, but you have to take into consideration if you are using the lignin from the process, you are adding some we are increasing the ash content as well, because it's probably brings the lignin from the process, bringing some chemical together. So we have to find a good point to see how much can you use and how it can interfere in the other properties of the pellet as well. But yeah, you can use lignin and other organic things as well to help to aggregate this material during the pellet process.
Nice. You didn't know it could be used as adhesive.
Thank you.
Problem.
Does anybody have other question for Rafael? I can read it for you if you want, Rafael. So one question from Julia. Do you know if there are many issues regarding the storage of pellets?
Storage the pellet. Yeah, the way that you store the pellet, it's gonna impact the quality of pellet as well. When you storage the pellet, it can, like after you made the pellet, you need to wait this pellet stabilize as well, because it's still able to change some properties, and you have to look for how many days, for example, the storage condition can affect the property of your pellets, like moisture content, calorific value as well.
Thank you, Rafael.
Other questions? I don't. Oh, Jean-Michel, maybe? No. I don't know. I saw in your presentation that one of the 10 Quebec producers of wood pellet was the city of Chapet. And just as a point of information, they just joined the MRQ network as a partner. So if you just want to keep in touch with them, you can tell me. You need the contact. I'm here for you. Do you have any question for Rafael? So I think that's all. And I just want to thank you a lot, Rafael, for your presentation, and thank you to everybody that was that take the time to be here with us today. In 3 weeks, on September 30, we will have the chance to hear Ira Hurtado, still from the Biomass laboratory, Biomass Technology Laboratory. The title of its presentation is From Syngas to Liquid Fuels. It will be at the same time at 10 a.m. So you can look on the by courriel, and with the social media, we'll share it. So I wish you a great day, everybody, and thank you, Rafael.
Thank you everyone for this place, for listening as well.